All right, today is December 6, 2011. We're going to work on our Chapter 6 review. So on page 384, 5b has a question like this. It says 3 to the power of x, or a variable is the x, is equal to 1/9. There's two ways we can go about solving this. We can try to make the left side equal to the right, or we can try to make the right side equal to the left. So here's our left side, here's our right side of the equation. Whichever way you feel more comfortable with. I'm going to show you guys both. That didn't quite work. So, and the first one I'm going to do is I'm going to make the right side equal to the left. So we have 3x is equal to 1/9. Now in this question, remember, if our variable is an exponent, we want to change everything to the same base that exponent is 2. So, in other words, we have a base of 9 right now, but it's a fraction. So the first thing I want to do is I want to change it from being a fraction. So this 9 is technically to the power of 1. In order to change it from being a fraction, what would I do to that exponent? Does anyone know how to change this fraction into just a whole number? What would I do to that exponent? So, this number 1 here, because this number is technically to the exponent of 1, if I want to flip this fraction, I'm going to change that exponent to -1. Okay? So now this exponent is to -1. It says 9 to the power of -1 over 1. Well, I don't really need it to be in fraction form anymore. I can just work with 9 to the power of -1. Okay? The next thing I need to do is I need to look at our 9 here. I need to change it to the base 3. Anyone know what base 3 would be equal to 9? 3 to the power of what? 2. 3 to the power of 2. So we can replace 9 with 3 to the power of 2 to the power of -1. Now, if you guys remember our exponent rules, a power of a power right here, we're going to multiply the two exponents by each other. So we end up with 3x is equal to 3 to the power of -2. Okay? Now that the bases are the same, we can drop both bases off. And we get x is equal to -2. It says express as a radical. You have base 8. It is to the power of 5 over 3. So in these cases, we have to remember our rules for radicals. Okay? So we have a radical exponent here. And what this says is x to the power of a over b is equal to the root of b to the power of a. Or in other words, it looks like this. We have our a value. What's our a value in this question? 5. That's right. We have a b value. What's our b value? 3. Okay. And our x value is 8. So we're going to rewrite this down here. We have 8 to the power of 5 over 3. So what they've done in this question is they rewrite the base. It's to the power of a. So our a variable is 5. So we're writing 8 to the power of 5. Our b variable is the radical. So it's to the root of 3. In other words, that means it's the third root of a number. Okay? So the third root of a number means we have to multiply some number. We'll call the number y. Y times y times y would be the third root of something. Okay, so we'd have to split this number underneath the brackets 3 times. Now, I didn't actually ask you to solve this. I just wanted you to express it as a radical. This is in radical form. We have the third root of 8 to the power of 5. Okay, let's say part B of this will be to evaluate it. So we'll get rid of this. That'll say evaluate. And when we're evaluating this, what we're going to need to do, if you guys have a calculator, I want you to follow along. Take it out because you're going to need it for the test tomorrow. Okay, I'm holding.
Test tomorrow?
Or Monday, sorry. So, when we go to evaluate this, what we're going to do is we're going to work with what's under our radical first. We have 8 to the power of 5. So we're going to evaluate 8 to the power of 5. We're going to plug it into our calculators. So on the calculator, we're going to hit 8. You're going to hit either the button will say y to the power of x, or it'll look like the little roof of a house. I've shown you guys this before. Your button will either look like this or like this on your calculator. So we put our base in first, which is 8. Then we hit that button, which now means we're in the exponent. And I'm going to put the exponent 5 down. It equals. So 8 to the power of 5 is 32,768. Now with our calculator, we have to find the third root of this number. Okay? Again, you guys, this is why I want you to be using your own calculator. I want you guys to be able to get around it easily. So there are 2 ways you can put this in the calculator. You'll either have a button that has an X and then a radical symbol like that. Okay? I think we have that here. Or you'll have a button that looks like X to the power of Y. You're going to be hitting those 2 buttons, one of those 2 on your calculator. So we're going to type in our number first, which we already have put into the calculator, 32,768. We find that button. I'm now in my radical form, radical of 3 equals, and we got a decimal here. Okay, so if you take a look, it said 31.9 repeated. Calculator should have rounded. You guys will end up with 32 when you evaluated this, okay? What's very important is you guys make sure you're using a calculator you're going to use on the test, because you need to know which of these buttons you'll be pushing when you go to put it into exponent form and when you go to put it into radical form. Okay, so we have our third example. We have base 9 to the power of 7 over 2. Part A tells us to express as a radical. So we're going to use that formula we know again for radical exponents. We're going to have to define what our A, B, and our X are in this question. So I'm going to rewrite the question over here. 9 to the power of 7 over 2. And let's relate them. Our A variable is what? 7. This is our A. So A is equal to 7. Our B variable is what? What is it? 2. Good. B is equal to 2. And what is our X variable? Only one number left. It's got to be 9. X is 9. Good. So when we go to express it as a radical, that's the right side of this equation here. We use our B, which is 2. Then the radical symbol. X is still our base, which is 9 to the power of 7. So that's part A right there, expressing a number as a radical. That's all I want you guys to do for A. Part B, I want you to evaluate. Now remember, I told you there's 2 ways you can evaluate. I'm going to split it in half. So the 2 ways we can express this. First, we can decide to solve the base to the power, or we can solve the radical first. In our first example, what we'll do is we'll do the base to the power first. So we have radical 2, 9 to the power of 7. Okay? So on your calculators, what we're going to do is we're going to solve first our 9 to the power of 7. So we're going to type that in. We get 9 to the power of 7 is equal to a very large number here. So we get second root, we've got a very big number here, 4,782,969. Okay? Very large number. Next thing we have to do is we have to find the square root of that. You probably have a button for just square root, but if you want to get used to the way we're doing it, you can still use that radical button to the root of 2, so we use the number 2 instead. So the square root of this number, we go to find the square root of this, we get 2,187. The other way we could have solved this is we could have put our base to the radical 2 first, then to the exponent. So I'm going to rewrite it a little differently. We change this to the root of 2 to the power of 7. Both of these will get you the right answer, whichever one you're more comfortable using. Okay? So in the first one, we solved for the base to the power of 7 first. In this one, we're going to solve for 9, the square root of 9 first. Samples. Okay, so in this example, we're going to find the square root of 9 first. Anyone know off the top of their head, square root of 9? 3, good. So we have 3 to the power of 7. I don't know that off the top of my head. So we're going to put that into our calculator. 3 to the power of 7, and look at that. We got the exact same answer as we did before. 2,187. Either method you can use to solve this. Okay, here's our fourth example. This is a simplifying question. What's important is the question states to express as a positive power. Okay, so I don't want you to evaluate. Okay, express as a positive power. So there's no evaluating this. If you guys notice, all of our bases are variables. So our answer is going to be written in these two variables. We have an A and a C. I eventually want your answer to be A to the power of something and C to the power of something. Okay? Your answer is going to be written like that. We need to evaluate everything in here using the rules from this side. Our multiplication rule, our division rule, and our power of a power rule. Okay? So I'm going to rewrite the question down below again. We have A to the power of 3 times A to the power of 2. Both of those are to the power of 6. Multiplied by C to the power of 2 to the power of 1. Divided by A to the power of 3 times A times 3 to the power of 3. So you guys really need to separate our variables, okay? I want you guys to think of them differently. We're going to deal with just our A's together and just our C's together. I'm going to evaluate the top part of the bracket first. There's a lot going on there, so we're going to simplify that. So, first thing we're going to simplify is we have a multiplication rule. A to the power of 3 times A to the power of 2. We're using a multiplication rule, which means I can simplify that as one base, A, and I'm going to add the two exponents together, 3 plus 2. Okay? We're going to do this all one step at a time. A to the power of 3 plus 2 is going to give us A to the power of 5. Okay? Now from there, yes, because this is to the power of 6, this question, we're going to be using our power of a power rule. That means I need to multiply the two exponents. So that power of 6 comes inside, and we have 5 times 6. Okay? And we still left with C to the power of 2 to the power of 1, divided by A3, A, C3. Okay? Now along those lines, well, we have A, 5 times 6. Anyone know? Good. So we have A to the power of 30. Now I want you guys to look right beside it. We have the variable C. It's the same idea. It's a power of a power. So we're going to multiply those two numbers together. We have c to the power of 2 times 1 divided by a3, a, and c3. What is 2 times 1? 2. Very simple. So on the top of our fraction, we've simplified as far as we can go so far. A to the power of 30, c to the power of 2. Now, on the bottom of the fraction, we're going to work with our a's again. I have a to the power of 3 times a. What exponent is this a technically to? 1. That's right, good. So this is to the power of 1 technically. So in order to simplify that, again, that's a multiplication rule. That means we're going to add our two exponents together at the bottom. So we have a 3 plus 1, okay? And then we just have c to the power of 3. When we evaluate that, a to the power of 30 times c to the power of 2 divided by a to the power of 4 times c to the power of 3. Okay, now what I want you guys to do is we need to use our division rules, okay? We technically have a to the power of 30 divided by a. Now I can only keep bases that are the same together. So we're only going to evaluate the a's with the a's and the c's with the c's. Like we said before, we're going to have an answer that has an a variable and a c variable. So because this is divided by, according to our division rule, we're going to subtract the top exponent from the bottom exponent. So 30 subtract 4. So you can rewrite this again as just the base a, 30 subtract 4. And I'm going to do the same thing with our c. It's the exact same rule. We have our top exponent and we subtract the bottom one. So we have c to the power of 2 subtract 3. Okay? We evaluate these two. What is 30 minus 4? 26. A to the power of 26. What is 2 subtract 3? Negative 1. So, some people might stop here, but if you guys recall, the question way up at the beginning says to express as a positive power. So, we got to go into our negative exponent rule. Go way down to the bottom. Technically, this is a negative exponent. I want you to express it as a positive. If you guys remember our rule here, we can change a negative exponent into a positive exponent if we change it into the reciprocal, or we flip the base. Okay? So we're still going to have a to the power of 26. I'm going to separate them a little so we know what we're working with. How can I change c to the power of negative 1 to a positive exponent? That's right. 1 over c to the power of 1. Okay? Finally, this would be the final mark if you could get this. We would multiply these two together. It can be simplified one step farther. Because technically a is, as a fraction, what's it above? 1, that's right. If we were to multiply fractions, we multiply the top numbers by each other and the bottom numbers by each other. What is a to the power of 26 times 1? A to the power of 26 divided by, what's c to the power of 1 times 1? C, or just c to the power of 1, either way. So our final answer, a to the power of 26 divided by c to the power of 1. That will be the most difficult type question you'll have on this test. That is at least